In some cases, we may need to create baffles, which are essentially duplicated mesh boundaries. Generally, they are necessary to define internal boundary conditions, that is, boundary conditions on mesh surfaces located inside the computational domain and not on the domain boundaries. There are two applications of baffles in SIMFLOW. We may need to simplify a geometry and model some walls as infinitely thin, even though they have certain thickness in reality. For example, we can see the catalytic converter geometry here, and we may want to add an additional part to this geometry which will be located inside. Let's load another geometry, which is a plate with small pipes mounted to it. We can click Yes to merge all the surfaces of the geometry into one body. The geometry is invisible because it's located inside the catalytic converter, so we have to make the catalytic converter geometry semi-transparent. It only requires changing display properties and lowering the opacity level. As we can see, the plate and small pipes are all surfaces, which means that they are infinitely thin. The fluid will flow from the inlet pipe, enter the pipes mounted to the plate and flow farther downstream, towards the outlet pipe. It's worth noting that the fluid will be present on both sides of the plate and small pipes. Therefore, in order to simulate this case, we need to create baffles. Baffles in SIMFLOW can be created during mesh generation. Let's move to the hex meshing panel, enable the Mesh Geometry button for the catalytic converter geometry and the geometry that we want to use to create the baffle. If we expand the list of options available for this geometry, we need to select the Create Baffle option. It will allow us to automatically create two separate mesh surfaces for this geometry during meshing. Of course, we have to type initial mesh parameters, which we can see here, and move the material point inside the catalytic converter geometry. If all these settings are correct, we can switch to the Mesh tab and click the Mesh button. Once meshing is finished, we can examine the created mesh boundaries. The first boundary is simply the mesh created on the catalytic converter geometry. However, the remaining two boundaries are baffles. By creating a baffle, we simply created two exactly the same boundaries, with faces and nodes located at the same positions in space. So, the mesh is now on both sides of the geometry, and if we assign wall boundary condition to these baffle boundaries, we will be able to simulate flow on both sides of the plate and small pipes. This approach gives us the possibility to simplify the geometry and simulate it as an infinitely thin wall, and also allows us to use a coarser mesh. Another application of baffles is a situation when we want to simulate, for example, a pressure jump across a simplified infinitely thin fan, which is located inside the computational domain. Let's move to the Geometry panel and delete the geometry we used to create the baffle. We can also hide the mesh and display the catalytic converter geometry. In order to define a pressure jump across the fan, we need to load another geometry which will represent the fan. As you can see, the fan is just a single surface, located in the central section of the catalytic converter geometry. Again, in the hex meshing panel, we can define that we want to create a baffle on this surface and create the mesh. Once meshing is finished, we can see that two separate mesh surfaces have been created, and we can use them to assign different boundary conditions, such as inlet or outlet, even though they are located at exactly the same position in space. However, in order to define a pressure jump caused by a fan, we should go to the Mesh panel, press Ctrl, and select these two baffle boundaries. Additional buttons, which appeared here, allow us to couple these two boundaries by creating an interface. If we click the Create Cyclic Interface button, then go to the Setup panel and select a solver, for example SIMFLOW, we will be able to define a pressure jump across the fan in the Boundary Conditions panel. It's important to note that by creating baffles we create new faces, but they share the same nodes. If we are going to perform a simulation using dynamic mesh, and the baffle is meant to be an interface between rotating and stationary domains, the nodes of the rotating domain will move, but the nodes of the stationary domain will not change their positions during the simulation. Therefore, if we are going to perform a simulation involving baffles and dynamic mesh, we should enter the Mesh panel and separate nodes between the baffle surfaces. We can do this if we expand the list of options for the default mesh region and click Split Baffles.